it green now? Thank you. A little bit of vocabulary first. I just put general variables here, so don't worry what's x, what's n, whatever. It's just general variables. What do we call the x? So what's the big number an exponent is attached to? The thing. A little more specific than thing. It's called the base. All about that base. What's the n? It's the exponent. And then when we take the whole thing together, the base and the exponent and the answer on the other side, anyone know what that is called? What's the name of the unit? It's called the power. So if I put numbers in instead of variables, 2 to the 3, 2 is the base. It's the big number that the exponent is attached to. 3 is the exponent because it's superscript and a little bit higher. And when I evaluate that, 2 to the 3, you should have looked at in grade 8, is 2 times 2 times 2. What's the value of 2 to the 3? 8. That whole thing together makes the power. So 2 is the base. Take them off, please. 3 is the exponent. 2 to the 3 equals 8 is called the power. What's the definition of an exponent? Why do we have them? What's the point? Why do I have this little 3 up here? Why can't I just write 2 times 2 times 2? Because we're lazy mathematicians. We're very lazy. And if there's a short way to do something, we do it. So we know, what does this 3 really mean? Because it's not 2 times 3. You should have looked at that in grade 7 and grade 8, and that's drilled in. This is not 2 times 3. What does the 3 mean? How many times? To multiply the base. How many times to multiply base? So definition of exponent, it's repeated multiplication. Do you hear like some kind of animal? Like, is that a cat? What is that? Repeated multiplication of a base. It's just a short way to write multiplication because we're lazy, lazy people. So 2 to the 3, for example, is not 2 times 3. It's 2 times 2 times 2. What's that little dot thing? What is that? What is going on? Yeah, why don't we use the x anymore? X has been great since grade 4. You've been always looking at the x. Why do we suddenly kind of throw that notation out? It gets confused with the variable of x. So a dot means multiplication. Occasionally we'll use an x, but not really. It just all means multiplication. We're going to do a bunch of things today. First, what we're going to do is simplify. Then flipping to example 2, we're going to do the opposite, which is expand. And then we're going to do what's called evaluating. And those all mean different things. That's why I'm just highlighting the keywords. So we had simplify, expand, evaluate. What does simplify mean in general? If I said simplify, we did it with polynomials, we did it with fractions. What does simplify mean? I'm not sure if you're still awake today. Make it smaller. Perfect. Make smaller. So that's what we're doing for these first examples, is taking a bunch of repeated multiplication and just writing with an exponent. You did this in grade 7. You've done it in grade 8. This is just to practice. How can I figure out what exponent I need to use for A? Count up the number of 2s. So go ahead and count up the number of 2s. Now, usually I get many different answers. So let's see if we can all confirm the same answer. Give me an offer. 7. I heard everyone say 7. Awesome. So I'm going to write this as 2 to the 7. Oh, Eric. B, just be careful. If there's brackets in the question, there's going to be brackets over here in the answer. So all I want to do is make this more simple. Instead of writing -1 times -1 times -1, what's the short way to write that? Negative 1 to the 3. So I'm going to keep those brackets, and I'm going to make it a cubed. Why? Why do we call an exponent of 3 a cube? What do we call an exponent of 2? Squared. We would call it negative 2 squared, for example, or negative 1 squared. Why do we call it squared and cubed? Where do those numbers or those words come from? Yeah, so how many dimensions does a square have? If you were to draw a square on the piece of paper, it would have a length and a width. How many dimensions is that? 2. If you were to draw a cube or to look at a cube, it's got length and width and height. How many dimensions? That's why we call it cubed. It comes from the dimensions. Why don't we have special names for 4 and 5 and 6? Because we don't know those dimensions exist yet. We're thinking there's a 4th dimension. Does anyone know what it is? Anyone know what's called the 4th dimension? It's time. So if you were to move a cube over time, that's called the 4th dimension. But that's why they have special names. It just comes from the dimensions. Go ahead and do letter C. Simplify this. Make it smaller. Write it with an exponent. Be lazy. What is my base going to be? 3/5. And if there's brackets in the question, I'm going to keep brackets in the answer. And then all I need to do is count them up. How many 3/5 do I have? So I would read this as 3/5 to the 4, or 3/5 to the exponent of 4. Simplifying. I get it. I kind of get it. Put it high, high, high so I can see. Awesome. This is not new, correct? Want to double check? You've seen this before? You've seen expanding before as well. What does expand mean? Make it bigger. Stretch it out. Waste paper. Purpose of this is right in the directions as we tend to expand just to show that we understand what it means. So 3 to the 6, we want to show we understand that's not 3 times 6. If it was that easy, we would love exponents. How do I show 3 to the 6 in expanded form? 3 times, 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 times. Trick question there, 6 of them. That is one way I could write it. I could also write it with brackets if I wanted to. So I could have each of the 3 in brackets. Mathematically, they mean the exact same thing, so I would accept either answer. We tend not to put the x only because later on it gets really confusing with the variable of x. So either use the dot or use brackets to separate, completely up to you. Negative 2 to the 4 is not negative 2 times 4. What does it mean? Negative 2 times, negative 2 times, times. And if there's brackets in the question here, there tends to be brackets here, so I'm going to use that. Negative 2 times negative 2 times negative 2 times negative 2. Here's why we tend to use brackets, especially when there's negative. If I write it out like this, and your brain doesn't pick up on those little multiplication sign, what operation does this look like? Subtraction. So we get a little bit confused. Are we subtracting or are we multiplying by the negative? So we tend to use brackets with negative just to keep it really separate and to understand that we're multiplying. This one does not have brackets. So this is a little bit of a tricky one. What it means is the negative does not apply to that exponent. All it means is the answer here is going to be negative. The exponent is only attached to that 5, so that's the only thing I'm going to repeat. So this will be negative 5 times 5 times 5. Why did I include the negative in B and I did not in C? Brackets. Because of the bracket. So because there's no brackets, I just stuck the negative in front just like he was in the question. Brackets means the negative repeats. No brackets means it doesn't. It's just out front. Thumbs up. Get it? Kind of get it? Don't get it. Put them really high so I can see. Letter C. All I did was just write that negative in front. One time, because there's no brackets there. So 1 time negative and then 5 times 5 times 5. What we're going to focus on the rest of the day is what's called evaluating, so I want to highlight that. So we've done simplifying, make it smaller, expand it, make it bigger. What does evaluate mean? Solve it, I like that. Anybody else have a different word? What does it mean when you solve something? Find the product, I like that. What did you say? Get the answer, I like that. So it means find the numerical value. There's it in fancy math speak. Find the numerical value. What does numerical mean? It means it's a number. So you're looking for a number in the end. Sometimes if it just says find the value, there could be variables in there. That's why we specify these are going to be a number when we're done. So we're going to practice on the easy ones you should have done last year, and then we'll get into the harder ones. 3 squared. We're not looking to expand it. It's not what the question is asked. So the question is not to put 3 times 3. The question is to actually figure out what does that equal. So in your head, you can visualize 3 times 3, because there's 2 of them. What's 3 times 3? 9. Not 3 times 2, 3 times 3. 2 to the 4, what does that mean? 2 times 2 times 2 times 2. So in your head, picture 4 2's, and let's multiply them left to right. 2 times 2 is? Times 2 times 2. 4 squared, and we talked about why do I call that squared? Where does that word come from? 2 dimensions. Square is 2 dimensions. So in your head, picture 4 times 4, which is the expanded form, and then just multiply. What is 4 times 4? 16. Do you see the difference between expand and evaluate? Okay, if we look up here with expand, where are we finding the answer? Did I ask you what 3 to the 6 was? No, that means evaluate. Expand is just write it out in big form. 1 to the 5. So you're going to picture 1 times 1 times 1 times 1 times 1. So 5 ones in total. What's 1 times 1? Times 1. Times 1. Times 1. 3 cubed. Where does the word cubed come from? Why do I call it a cube? 3 dimensions. Now what your brain is going to want to do is put down 9. Because you see a 3 and a 3, and you're so used to doing 3 times 3 equals 9. But that's why you need to picture the expanded form. What does 3 to the 3 equal? 3 times 3 times 3. So 3 times 3 is 9 times 3, 27. There's the difference between multiplication and an exponent. 5 squared. Picture the expanded form in your head. 5 times 5. What does 5 times 5 equal? 25. Do you see the difference between expand and evaluate? Expand means show the long way, make it bigger. What does evaluate mean? Bless you, give me a number. So we're now going to talk about these little tricky negatives that we talked about a little bit earlier. And I put just a little guide for you in the box to help you remember. It like upsets me so much, my highlighting just went crooked. Let's look at the difference between negative 3 squared and negative 3 squared. And listen to how I said those. Negative 3 squared, negative 3 squared. When I say it, do they sound different? No, that's why you need to be really careful whether there's brackets or not. What this means in this question when there's no brackets, it means the opposite of three times 3. That's what the little negative in front is. It's the opposite of 3 times 3. So what is 3 times 3? 9. What's the opposite of 9? Negative 9. That's what it means when there's no bracket. The negative is not included with that exponent. It's just a negative in front. So just like the example before, it was in the front here, it's in the front here. Let's take a look over here. Because of the brackets, what does this one mean? Negative 3 times negative 3. The left hand had 1 negative. How many does this one have? It has 2. And what happens when we do a negative times a negative? Turns out to be a positive. So if there are no parentheses, like example number 1 or the left-hand side, the answer will be negative. If there are parentheses, you just need to know whether the exponent is even or odd. And what's going to happen with an even exponent like this one is the negatives are going to match up. So we're going to have an even amount of negatives, and every two negatives make a positive. So if there's an even exponent, the answer is going to be positive. What if it was an odd exponent? So let's pretend for a second this was negative 3 to the 3. So we would have had negative 3 times negative 3 times negative 3. What would have happened with those negatives? The first two would make a positive. What about the last one? He would be negative because there's no pair. So if there's an odd exponent, the answer will be negative. If you memorize that little box, you will never get these wrong. No parentheses, it's going to be negative. Parentheses with an odd exponent, negative. Parentheses with an even exponent, positive. What's the difference between a bracket and a parentheses? Well, there actually is, but we as Canadians are very sloppy with our words. So I've called this a bracket, I've called it parentheses. We kind of interchange those. In the rest of the world, they have different words. So in the rest of the world, and you don't need to know this, but I just want to explain why I use parentheses here. What are these? They're parentheses. What are brackets? What do brackets look like? The squareds are brackets. What are the curly cues? They do. Well, we tend to call them all brackets, right? But they're actually not. These are parentheses. These are brackets. These are, guess. Fancy curly cue butterflies. They're called braces. And I always think of braces on teeth for some reason. So really, in the rest of the world, these are parentheses. These are brackets. These are braces. What do we call them all in Canada? Brackets. It's interesting when you start to travel those, you realize we're the only country that uses bed masks with a B. Because are these really brackets? No. What does the rest of the world use? Ped mass, because they are parentheses. We use them interchangeably. Just a little fact for you. If there are no brackets or no parentheses, the answer is going to be negative. If there are brackets and the exponent is even, it will be positive. If there are brackets and the exponent is odd, it will be negative. Those are the three rules that's going to help you out with these negatives. First thing I do is look at brackets or no brackets. No brackets tells me right away the answer is going to be negative. Now I forget about that negative and I just look at the 4 times 4. What's 4 times 4? 16. So this is the opposite of 4 times 4. And what's the opposite of 16? Negative 16. That's why the negative stays. Brackets or no brackets? What does that tell you automatically about the answer? Now ignore that negative. You've taken care of it. Now we just need to do the 7 to the 1. What does 7 to the 1 mean? It just means 7 times what? Itself. It's just 7. So this is negative 7. Why is it negative? No parentheses or no brackets. It means the opposite of 7 to the 1. And what's opposite of positive 7 to the 1? Negative. Brackets or no brackets? Brackets. Even or odd exponent? Odd. What does an odd exponent tell you about the negatives? It's going to be negative. And the reason that is because there's going to be 3, and they need pairs to make a positive. Now I just worry about the base and the exponent. So ignore the negative. You've taken care of it. What is 1 cubed? 1. Why isn't it 3? Because that's what your brain's going to want to do. Your brain's going to see 1 to the 3 and go 1 times 3. It's 1 times 1 times 1. Negative 5 squared. Brackets or no brackets? What does that tell you about the answer? Now just worry about the base and the exponent. 5 squared is? Turn and talk to someone. Do the next two together. Negative 2 cubed. Brackets or no brackets? Even or odd exponent? Odd exponent tells you the answer is going to be 2 to the 3. Again, your brain's going to want to put 6 because it sees a 2 and a 3, and you know that's 6. But you have to stop yourself, and you stop your brain by picturing the expanded form. If you picture 2 times 2 times 2, you're less likely to put 6 down. What is 2 times 2 times 2? 8. Final answer is negative 8. 10. What the heck? First, you worry about the brackets. Brackets or no brackets? Even or odd exponent? Even. What does that tell you about the answer? And you don't need to put this. I'm just going to write the positives. When you look back, you understand we've talked about that. 10 to the 4, don't put 40. And you're going to stop your brain by putting 40 by picturing the expanded form. Picture 10 times 10 times 10 times 10. What's the trick with multiplying bases of 10? Add 0. So if there's 2, you make 2 zeros. If there's 3, you make 3 zeros. If there's 4, like this one, you put down 4 zeros. So a 1 with 4 zeros. What number is that? 10,000. Questions so far? Well, how do you do this on your fancy-dancy big boy calculator? This is the type of calculator you need for grade 9. It's called a scientific calculator. You'll know it's scientific because it's got these fancy buttons in here that look like sine, cos, tan. It's got a bunch of other buttons. It's always got a pi. It's got an ln. It's got a log. If you're just buying a calculator from Dollarama, sometimes it's not a scientific. It's just a regular calculator. That typically just has this bottom section. So it's got your numbers 0 through 9. It's got your add, subtract, multiply, and divide. You need to step it up this year. You need a scientific calculator. Do not pay more than $10. You can buy fancy ones. They have no function that you're going to need, like $7.99, $8.99. I've actually seen them for $3 at Dollarama. You need to get yourself one of these because you can't use your cell phone on the test or the quiz. For now, if all you have is your cell phone, grab your cell phone, open up the calculator function. Yeah, you're already ahead of me. I don't know. Can you kind of see that? I don't know how to do it on an Android. I'm assuming you know how to get a calculator. And you either have to go to the some kind of menu and change it to scientific, or on an iPhone you just turn it sideways and you get all those magical buttons. So you have to take your screen lock off if you've got it on. If you are going on to pre-cal and applied next year, who is already registered for pre-cal and applied? You are going to need a graphing calculator next year. You do not need it this year, but there's no point paying $10 for this and then turning around and paying $120 for this next year. So you might want to just buy this right away. The cheapest you're going to find these are through the school because we get a discount through Staples. So if mom and dad decide they want to purchase that this year, again, it's not needed, but if you're going to need it all the way through grade 12, if you want to buy one this year, come and see me. I will give you the form. This is all you need, but if you're going on to pre-cal and applied, this is what you're eventually going to need. So you might as well start with this one now. Who's going on to essentials? This is all you're going to need in essentials. So buy it now, buy a regular standard calculator. Questions on your calculator? So I'm going to show you today on whatever calculator you have. If you suddenly buy a new one for the test, make sure you know how to do this before the test comes. I cannot on a quiz or test stop and tell you how to use your calculator. That would be like stopping in the middle of a band concert and me telling you how to play your instrument. Or stopping in the middle of a hockey game and telling you how to use a hockey stick. Can't do that, okay? So make sure if you're bringing a different calculator, you know how to use it beforehand. I'm going to assume most of you have your phones today, so I'm going to do it on mine. Again, I have an iPhone. I don't know an Android, but we'll figure it out. What you're looking for is a button that either looks like x to the y, or y to the x, or sometimes x to the n. Something that looks like that. It's not just the x squared. It's not an x cubed. It's x to some kind of variable. So I don't know if you can see this. Ooh. Oh, I can't turn it down. Oh, like my brightness. Just a second. Like how far down? Like all the way down? Oh, you can't see that. You guys are so smart. Can you kind of see that? Okay, where on here do you see a button that's either x to the y, y to the x to the n, or looks something like that? So the second row, do you see you have an x squared, an x cubed, and then an x to the y? So if you're on Android, can you point it out to somebody who has an Android? Nowhere. It has to be on there somewhere. So an x to the y, an x to the n. Did you have a scientific? Did you tilt it? I did. Okay, if you come here and I find it, I will make fun of you.
I'm going to download it.
It's there. I know it's got to be there. It's a standard scientific calculator.
Should be y to the x.
Y to the x, x to the y, x to the n, something like that. Has everyone found the button on their magical calculator? Whatever your button is, write it down to the side. So mine was x to the y. No, you really don't have it. Like, why? Can you download a scientific? Okay, awesome. So you write down whatever your button is. Just know when you bring a scientific calculator in, the button may be different. So if we look at this one here, where do you see? Oh, you might have this one. Hang on there, Rory. Do you see with this one the little hat key? We call it a hat or a caret. That's the same button. Do you have that one, Rory? The hat, little hat or caret? Okay, so that's what you can use. So if you've got this one, write that one down. It's completely up to you, and it matters what calculator. Okay, has everyone found a button that may potentially work here? So I'm just going to write down the possibilities so that you know if you grab somebody else's calculator for a test, you know what you're looking for. It's either x to the y to the x to the n, or sometimes that hat or caret key. So first example, 6 to the 4. 6 to the 4 is not something we would expect you to multiply in your head. 6 times 6, you might be okay, but then you got another 6, and then a 6 after that, you're probably going to bail. 6 to the 4 would be a calculator question. So what you do typically with all of these keys is you type the base first. So I'm going to type the 6. Then you type that exponent key to tell your calculator, I'm about to give you an exponent. For this one, it's the hat key. Yours might be x to the y to the x to the end. Then you're going to type the exponent. And then typically you have to hit enter or equals or something like that. I don't even know if you can see that. Mine's 1296. Okay, if that didn't work, clear it out. Let's try it again. 6, whatever your exponent key is, then 4, then equals. You need the exponent key to tell the calculator what's coming next as an exponent. Otherwise, it's just going to think you're typing 64. What we don't want you to do is type 6 times 6 times 6 times 6. Okay? We're out of that in high school. That's the long way to do it. That's the baby way. That's why we have a scientific way. It's an easier way to type that in. Did anyone not get 1296? Okay, come show me what you typed in. Okay, so did you type the base? Which is 6. Did you do that? Now hit your exponent key. So you're looking for one of these. Yeah, whatever one looks like one of these. Okay, now hit 4. And then equal. Confirm, 1296. I heard a no, or I heard a yup. Yep, we're good. Now again, the little negatives here will be a little bit tricky if you're not careful how you do it. If there's no brackets, you don't put brackets. If there's brackets, you put brackets. So this one has no brackets, so I'm going to start by typing the negative key. Now the negative key on the calculator is not the same as the subtract, because to the calculator those are two different things. You should have something that looks maybe like a negative in brackets. It could look like a plus negative. It could look like a negative that's higher and longer. I'm just seeing what on this one what it is. So on the apple above the H, you've got a plus minus key. Android, can somebody tell me what it looks like? Nobody has one or nobody cares? Above the 8 if you're on an Apple device. Okay, so I'll do it with this one first. You're going to hit that negative key first, so it should put a little negative. And you'll notice a negative, well, you can't see on there, but it's slightly higher and slightly shorter than a subtract key. That's how the calculator knows. Now I'm going to type my base of 12. Now I'm going to hit my exponent key to say, calculator, hey, I'm about to type an exponent. And what exponent am I given? 5. So a negative 12, exponent 5. Negative 248,832, confirm. So I'm just going to make a little note for that little negative. You might have had a key that looked like this. You might have had a key that looked like that. Did anyone have anything different than those two? If there's no brackets, you don't put brackets. You follow exactly what's there on the piece of paper. If there's brackets, we need to put brackets. So I'm going to start by opening a bracket, putting my negative for -4. Can you even see this? Am I doing this for nothing?
Yeah.
Then I'm going to put the 4. Then I'm going to close the bracket. So far I've typed exactly what I see. Open bracket, -4, close bracket. How do I tell the calculator that I want to put an exponent in? Hit your exponent key, whatever that is for you. And then the exponent is 6. So because there was brackets in the question, I'm putting brackets in the calculator. We already know, is this going to turn out to be positive or negative? It's got to be positive. Why? Brackets and even exponent. 4,096. Do you hear like some bad music? Sometimes I think it's just me that hear these things, and I think I'm very good. Questions so far? If you bring a different calculator, make sure you know how to use it. So don't ask me 2 minutes before the test. Don't ask me during the test. Come and see me well ahead of time so I can show you what button you need to use. But I cannot during a test tell you how to use your instrument. Questions? There are 4 skills that we've learned this morning. Let me repeat what you need to know. You need to know how to simplify an expression using an exponent. You need to know how to expand an expression with exponents. You need to know how to evaluate without a calculator and how to evaluate with a calculator. Questions? Look at the calendar